compression test on a 4-cylinder engine. First step, remove all the spark plugs. My trusty assistant who is filming this is Christian, and he's already done that. God bless him. Okay, now we also want to disable fuel and spark. One of the easiest ways to do that is to get rid of the crankshaft sensor. So if you find out where the crankshaft reference goes, you can disable it. Okay, so on this car, this happens to have the coil pack up top. So we've disconnected the coil pack, which has the ignition module in it, and at that point, fuel and spark are disabled because the PCM won't see an ignition reference. Okay? Hopefully you guys will have learned that in my ignition class and have retained it. I'm not going to judge you if you didn't. So, what we do, we're going to start with a static compression test. Okay? So, compression tests are throttle wide open. We put a charger on the battery. This battery is terrible, so we're in great shape there. We want to make sure that the engine has the same rotating push for every cylinder. That's why we have a charger on it. Static compression means that we're just testing the engine the way it drove in. Okay, so we're not going to add oil. We're not going to add anything else to the cylinders just yet. We'll get to that test here in a little bit. So what we're going to do now is we've hooked up the gauge to cylinder 1, and I don't care if you start at 1 or 4 or wherever, as long as you get your numbers straight when you go to record your results, okay? So at this altitude, I like to look for 5 to 6 hits of the gauge, okay? So it'll step up incrementally as we get to the maximum number. The reason you want to do 5 to 6 hits at this altitude is we have 30% less oxygen than there is at sea level. So consequently, it's going to take it a little longer to draw in that air to go ahead and make that compression, all right? So now that we've done this, we've saved it, we've removed spark and injection pulse, we're going to go ahead and I'm going to step in, floor the accelerator, crank it for 6 hits, and we're going to go ahead and check our gauge. Alright, so we've gotten our 6 hits. So as you can see, we're at about 140 PSI. Now, on a used engine, this is pretty good, okay? This engine has 230,000 miles on it. It also has a unique feature, which we're going to show to you here in a moment, which is why we're doing this test on this car. Unfortunately, this car has outlived its usefulness as far as it's starting to get tired and it's a little old, so we're going to send it on to heaven. Now what you want to do is, obviously you've pulled all the spark plugs to start with, so if you've done that, you're in great shape, okay? So you just move from one cylinder to the next and we're going to go all the way down the line. Clear? Okay, so our results for this say 95 PSI in this cylinder. So what I can tell you, because I know what to expect from this engine, is we should have about 150 PSI across the board. Obviously we don't. So we're going to continue our test and see what the general mechanical health of the engine actually is on the rest of the cylinders. And then we'll talk about what that means. Because in drivability, and that's why we're really doing this, in drivability, if we don't have a healthy engine, we have absolutely no way to make it go boom, okay? Minimum compression to make the air-fuel mixture go off is about 100 PSI. Usually I find it needs to be around 115 to 120 realistically. realistically. But if all of these cylinders are not very close to each other, what happens is even a small variance in compression can give you a misfire at idle, because the ECM controls fuel as one bank at a time, okay? Alright, so our gauge on this one for number 3 shows 100 PSI. Typically, you'll find that manufacturer's specs say that anything that's a 30% difference is a failure. Well, we've already exceeded that. If we've got 145 here and neither one of these have hit 100, that's more than 50 PSI difference. So 350s, 50 plus 50 plus 50 equals 150, which is approximately what the first one showed us, right? So at that point, we're more than 30% off and the engine has major issues. Now let's do number 4 and we'll see what that shows. Clear! Alright, so we've come to our last cylinder, number 4, and we're at 150 PSI, okay? So if we have about 150 and a little less than 150, it looks like we have 2 good cylinders and the 2 in the middle are no good, okay? Now, we're going to go ahead and do another couple of little tests, and then we'll do a leak down test, and then we'll talk about our results, okay? So we've done a what's called a static test, testing the engine before we've made any changes. Now, if you guys will remember, when you did your engine builds, you lubricated the piston and the rings with engine oil or ATF to make sure that they would take the cylinder wall and produce compression. So what we're going to do is we're going to add ourselves a little bit of oil here, and then we're going to go ahead and run this test again. Now, if we find a large change in these 2 cylinders, because the end ones already test good, right? So if we have a big change in the center 2 cylinders, that tells us we've got bad rings. So the first thing we'll do is we'll test number 1. That will tell us whether or not we're looking at any changes in number 1 and whether or not we think we have a ring issue. Okay, so we're at about 145 now. We came up just a little bit, not really a big change. So what that should signal to you is this cylinder, if it has issues, is not in the rings, okay? It's not in the lower end for this one, because we're really, really close to the same reading. Usually, if you put oil in the cylinders and you do not have a compression problem, you will see about a 5 PSI change is what I've come to see over the years. Okay, and once again, we're at 95 on this one, so it didn't change at all. So if it doesn't change at all, that means that we likely have no issue with the rings. Okay? Not 100% sure, but 99% sure. You've added oil, compression doesn't change, the rings are okay. You might still have a hole in the piston, but beyond that, it's okay. All right, once again, we have 100 PSI, no change. So if there is no change, then we don't have a problem with the rings, do we? Our problem lies elsewhere. So we're gonna go ahead and double check number 4 just to be sure. But being as that was the strongest cylinder, I don't anticipate anything's gonna be any different. And I know this is repetitive, okay? Biggest thing is, when I usually run a compression test, I typically run it twice per cylinder, just to make sure that I don't have a piece of equipment that's leaking or mis-seated or something else in the head. If you can duplicate a reading, it's a good reading. Clear! All right, once again, we have 150 PSI. So, if we have 150 PSI, once again here, we know that we have no change in the compression, and if we have no change in the compression, then our compression reading is good, okay? So that cylinder is good for compression, this cylinder is good for compression. Now, here's what I'll tell you. Newer engines are running higher and higher and higher static compression. The reason they do that is because they're looking to cancel some of these cylinders and then run it in a lower mode. So each cylinder has to contribute more when it's not being used. Does that make sense? Or when its companion isn't being used. So this is a 10-to-1 compression engine. It should be making 150 PSI. Some of the older engines, and this is a 2001 Grand Am with a T engine. It's a variant of what's known as the Quad 4. It is the predecessor to the Ecotec, just so you know. Older engines that ran lower compression, 9.5-to-1, 9-to-1, 8-to-1, those pressures for good cylinders will be coming down, but the lowest I've ever seen is about 130. And that's on a 9-to-1, 8.5 or 9-to-1 engine. And that's sufficient to fire the cylinder. So just be aware of what you're working on. Some specifications will be available in service information and some will not. You'll have to just know in your head, or rule of thumb, as I've just told you, the higher the compression ratio, the higher static compression you're going to have, okay? Now, since we've decided that we don't have a problem with the lower end of the vehicle, now we're going to switch to the upper end of the vehicle, okay, of the engine rather. So we've tested the bottom end. The bottom end doesn't change with oil. So at that point, we don't have a ring problem. We have something else going on. So now we're looking at valves, whether they be intake or exhaust, or something else. So we're going to run a different test for that, and that will be in a different video. Thanks, guys.